Hi everyone, it's Mrs. Griffin with the Unit 1 Lesson 2 video about perpendiculars and bisectors. Your I can statement states that you should be able to define and solve problems about segment bisectors, perpendicular bisector lines, and perpendicular bisectors in this lesson. So as I'm going through, if you do need to pause in order to finish copying something, don't forget to do that. So we need to know some vocabulary, and the first one is the word perpendicular. Perpendicular are lines that intersect to form congruent right angles. So what that would look like is that I would have one line or a segment or array that intersects another, making an X, but specifically we would have right angles, and all four of them would be right angles, or if only portions, for example, something like this, then any angles that were created like that would be right angles. Okay. The symbol for perpendicular is very important to know, and it looks like an upside down capital T. So for this one, if I were to put a few letters in, if that was line AB and this was line CD, it would say that line AB is perpendicular to line CD. Okay, the next one is complementary. Complementary are angles whose measures have a sum of 90 degrees. So that could be two angles, for example, one here and one here. These are called non-adjacent, meaning that they add to 90 but they don't touch one another. Or that could also look like a right angle that has been split into two other angles, and those would be called adjacent ones. Okay, the next word is midpoint. Midpoint is a point that divides a segment into two congruent segments. So if we were looking at something like that, we would have a segment, for example, AC, and there would be a point perfectly in between them, and we would get two congruent parts, and we would mark them congruent with a tick mark. That's how we mark lines the same. So in this example, B is the midpoint of AC, and it's segment AC. Okay, and that would mean that AB would be congruent to BC. The next one, a segment bisector. A segment bisector is a lot like a midpoint because it does the exact same thing. It's going to take a segment, for example, our AC, and it's going to split it into two congruent pieces. So we're going to have this happen, but it's not the point, it's a line or part of a line that does that. So in this case, XY is a line that is bisecting, cutting in half, segment AC. So in this example, line XY bisects segment AC. All right, and I'll just put a B in there as well. So the same thing is going to happen. AB would be congruent to BC. So the only difference between a midpoint and a bisector is that a midpoint is just a point and a bisector is a line. Okay. A perpendicular bisector combines two different vocabulary words, and that's because it does two different things. It's going to bisect, meaning it divides a segment into two congruent segments, just like above, and also form those congruent right angles. So what would happen in that case is we would have our segment, and it would be split into two congruent parts, but it would be done at right angles instead of just at any old angle like above. So in this particular one, XY, the line, is the perpendicular bisector of AC. Okay, and the same thing as before happens. We end up with two congruent parts. Okay. Now, drawing the picture is half of the battle of answering the question. So these two problems have to do with the same picture. We're talking about finding things given that Q is the midpoint of PR. So I'm going to draw one picture for both of them. Okay, and a midpoint always looks like this. And it says Q is the midpoint of, and it's segment PR. That tells you the endpoints are P and R. Okay, and it does tell us for both of them the same thing, PQ is 5. Now remember, if it's a midpoint, it's going to divide it into two congruent parts. So both of these smaller sections would be 5. So when they want us to find QR, notice it has no hat on top. That means it's the measure of QR. That means we want a number for an answer. We would get 5. Okay, and then in this one, PR with no hat, nothing on top, means the measure of PR, which would be the whole segment, and you would just put these together. 5 and 5 would be 10. Okay, and because these are segment lengths, though not in degrees, they would be, the unit would be centimeters or inches or something like that. Okay, moving along. Another example using a midpoint. So if we draw a picture with a midpoint in it, it says B is the midpoint of segment AC. So A and C are the endpoints. So we're going to label what they've told us for our measurements. So the measure of AB is 2x plus 9. So over on AB, I'm going to put 2x plus 9. And then AC, which is the entire segment here, has a measure of 34. Okay, now if AB is 2x plus 9 and these two portions are the same, that would mean that BC also must be 2x plus 9. And together they make up the entire segment, which is 34. So if I were to add these two parts together, they would equal 34. And then I could solve my equation from there. So I can combine my like terms. I would subtract 18 from both sides, and 34 minus 18 is 16. And then when I divide by 4 on both sides, I get 4. Notice I did not show the extra little steps in here. That's good to do. You don't need to show them all if you don't need to, but if you do, please show them. Another way to do this would have been to realize that if the whole thing's 34, each piece here would have been 17. And so the 2x plus 9 could be set equal to the 17, and you could solve it that way as well. So you would get the same answer either way. Also notice, what are you trying to find? Because you want to make sure you don't need to substitute back in. Okay, next we have number 4. Line RS bisects segment EF at Q. So we have a segment EF that's being bisected by a line RS. And the bisect is happening at point Q. That means that segment EF is being cut into two congruent parts. Find the value of x if EQ is 3x minus 3 and QF is 21. Make sure you label the appropriate segments, and you'll notice EQ and QF are the ones that end up congruent. So I can set these equal to one another and solve from there. So I'd be adding the 3 to both sides and then dividing by 3 to get the x equals 8, and please make sure you're finding what they've asked for. Okay. On this one, XY is the perpendicular bisector of segment JL at K. So I have segment JL. Okay, and XY is going to be perpendicular and bisect. It's going straight through the middle and making a right angle and going to cut it in half. So this is line XY. And then if it's the perpendicular bisector at K, then that K is the middle there. So JK is x minus 3, and JL, that's the entire thing, is the 6x minus 38. So all of this together is the 6x minus 38. All right, so we're going to do something just like we did on number 3. If I know that this is x minus 3, I know this would also be x minus 3. And if I were to add the two parts together, that would equal the whole. So if adding x plus 3 and x plus 3, that should equal the entire length of the segment, which is 6x minus 38. And then again, just like all the others, we're going to solve the equation. So I'll combine like terms. I'm going to subtract the 2x from both sides. I'm going to add the 38 to both sides, and then I'm going to divide by 4. And again, I've skipped quite a few steps because we are in a higher level of math, but if you do need to show all that work, then please feel free to do it. Okay, number 6. For number 6, in the accompanying diagram, segment BD is perpendicular to line ABC. So I'm going to highlight those in blue. Segment BD and line ABC. I'm sorry, ray BD and line ABC. They are perpendicular. That's what that symbol means. And that means that they're forming 90-degree angles. So on each side, the angle formed here and here would be a 90-degree angle. We also have BE perpendicular to BF. So BE perpendicular to BF. That tells me that that is also going to form a 90-degree angle. So this in here is 90 degrees as well, this entire angle. Okay, now knowing that, they're telling us that FBC is 20. So 20 can get plugged in for FBC, which it is here. And then I'm going to do some calculations. So the first thing I'm going to notice is this here should be a right angle, and that a little part of it is 20. So 90 minus 20 gives me 70 for this section here. The second thing I'm going to notice is that this here is also a right angle. So together, this 70 and this little piece in here should also make 90. So 70 minus 90 is 20. And if I do the same thing this way, this is 90 as well. 90 minus 20 leaves me 70 here. So now I have all the little pieces. They want the measure of angle EBD. So finding that, EBD would be this angle in here, which would be 20 degrees. Okay. Number 7, line PQ bisects segment AC at B. So there's segment AC, and it's going to get bisected, so cut into two congruent pieces at point B by line PQ. Notice it doesn't say perpendicular, so I didn't make the right angle. If AB is 10 minus x and BC is 2x plus 37, we're going to find the value of x. So those are the two little pieces that end up congruent. So I can set them equal to one another because they are the congruent segments. And I'm going to add x to both sides. I'm going to subtract 37 from both sides, and I'm going to divide by 3 and get x equals -9. Now normally a negative number in geometry is kind of weird because we don't have negative measures, but what that means is if I were to plug back in, I'd get 19 for this one, and also 19 for this one. Okay, moving on. Number 8. Two complementary angles, remember that means they add to 90 degrees, have measures in the ratio of 2 to 4. That's like saying one of them is 2x and the other is 4x. And I know that together they're complementary, they have to have a sum of 90 degrees, so I can add them together. And I can get that 6x equals 90, divide by 6 on both sides, and get the x is 15. And then my angles were the 2x and the 4x. If I were to plug in that 15 for each, I can find that 2 times 15 is the smaller one would be 30, and 4 times 15, the larger one, would be 60. I'm going to do the same thing on number 9. Again, we have two complementary angles, and this time the ratio is 7 to 2, so 7x and 2x have to add up to equal 90. That would be 9x equals 90. Divide by 9 on both sides and get x equals 10. Now, the two angles were 2x and 7x. They want both of them, so I'm going to plug in the 10 and get that this angle would be 70 and this angle would be 20 degrees. All right, I will see you in class.